Definition of system. One lecture was made regarding this topic few months back, and it was posted to YouTube. But I think in that lecture, the lecture was incomplete. So this lecture is the revised form of the previous lecture. Definition of system. You will find this topic in the first chapter of Engineering Thermodynamics, which is taught in BTech courses, BTech first year courses. Again, to study the subject on fluid mechanics, you will need to know the same definition, system. Actually, system means what? System means something to look at, something of your interest. That something is the system. If you are interested to analyze the problem on a chalk, then the chalk becomes the system. If you are interested to analyze the problem of an engineering college, what's happening inside the engineering college, then the engineering college campus becomes your system. Okay. So how it is defined? It is defined as, a system is defined as a certain quantity of matter. Certain quantity of matter or a fixed region in space. Two types of definitions are there. It means two approaches are there. I should rather say two approaches are there. Two types of approaches. One is certain quantity of matter, another one is fixed region in space, upon which attention is focused or concentrated for the analysis of a problem. That means a system is defined as a certain quantity of matter or a fixed region in space of your interest. Okay. So, first we are taking the example, two approaches are there. So, we are taking the next example, second one. Fixed region in space. Fixed region in space. Suppose you are interested on a road where there is so much traffic. Cars, bicycles, motorcycles are continuously moving on the road. You are standing by the side of the road and you are watching what's happening on the road. So the second approach, where it is mentioned that a fixed region in space. So you now fix the region on the road. You draw two straight lines on the road. You draw two straight lines, say 100 meter apart, 100 meter apart, you draw two straight lines on the road. So that two straight lines and the edge of the road makes one closed boundary. Okay. And your interest is on that closed boundary. So now cars are going from left to right and few cars or bicycles or motorcycles are going from right to left. You are not watching those cars or motorcycles when they are outside your fixed region of your choice. You are watching them only when they are inside that region, that fixed region. What's happening with them? Where they are going? What is their velocity? Okay. What are their masses? What are their velocities, etc. It is your choice. What are the things which you will observe? So your main interest is not on those cars or motorcycles or bicycles. Your interest, what's happening inside that fixed region of your interest. When these cars are outside that region, you are not observing them. Only when they are inside that region, you are observing them, what's happening with them. So that fixed region becomes your system. That fixed region becomes your system. So that was the second approach. A system is defined as certain quantity of matter or a fixed region in space. So this is the second one. And the first one is certain quantity of matter. So when system is defined like that way, certain quantity of matter, then what you have to do? Problem is same. You are observing those cars, what's happening on the road. So if you are interested on certain quantity of matter, say you are interested on a car, say one ambassador is moving on the road and there are 4 to 5 people inside the car, including the driver. So this is certain quantity, that ambassador car along with those people inside the car. This is certain quantity of matter. This is certain quantity of matter. Okay. This is certain quantity of matter. So if you are interested on observing that certain quantity of matter, then in that case, what you have to do? You cannot stand still anymore on the road. The car is moving, so you have to move with the car. You have to follow the car. What's happening with the car? What's happening inside the car? People are doing inside the car something, so you are observing all those things. Whatever is happening inside the car, you are observing all those things. But the main thing is that you cannot stand still by the side of the road. Since you are interested on that car, means certain quantity of matter is that. Since you are interested on that car, so you have to move with the car to observe what's happening with that car or inside that car. So this is the first approach. So this is also a case of system. Now, in this case, that car along with those people becomes a system, and in the first case, where fixed region in space was mentioned as a system, in that case, that fixed region was the space, that fixed region was the system, not the cars. Okay, so these are the two approaches. When certain quantity of matter is defined as a system, this type of approach is called control mass system approach. Control mass system approach. And when a fixed region in space is mentioned as a system, in that case, that type of system is called control volume system approach. For mathematical derivation, it matters most. For mathematical derivation, say for example, when you are considering certain quantity of matter as a system, in that case, if it is required to apply Newton's second law of motion, in that case you can directly write force is equal to mass into acceleration. Force is equal to mass into acceleration, because in that case mass remains fixed. Since certain quantity that is fixed, so mass remains fixed. So since mass is fixed, so you can directly write force is equal to mass into acceleration. Mass multiplied by acceleration. But when a fixed region in space is the system, in that case mass does not remain fixed. Which time, sometimes density inside that fixed region increases. Density of what? Density of the cars. And sometimes it decreases. That means mass does not remain constant with time. Continuously mass is changing. For some time you will observe that there is no mass. And for some time you may observe that there is huge mass inside that fixed region. Okay. So in that case, you cannot write, if it is required to apply Newton's second law of motion for the analysis of the given problem, in that case, you cannot directly write force is equal to mass into acceleration. In that case, you have to use the very basic definition of force, and that definition is force is equal to rate of change of momentum. That means d dt of mv, where m is the mass, v is the velocity, and small t denotes time. In that case, you have to write that way. And there is, there is difference between these two. Because d dt of mv is equal to what? It is equal to m dv dt plus v dm dt. And this dm dt part does not become zero when mass is changing with time. If mass remains fixed, it does not change with time, then that dm dt part is zero. The remaining part is what? The remaining part is m dv dt. And dv dt is nothing but acceleration. So it becomes mass into acceleration. When mass is fixed, it becomes mass into acceleration. But when mass is not fixed, it becomes d dt of mv, which is equal to m dv dt plus v dm dt. You have to take care of rate of change of mass also inside the fixed region and space. So this was all about the definition of system. You have to be very careful for any mathematical calculation regarding any system. Okay? First you have to know whether your system is a control mass system or it is a control volume system. Okay? Thank you. If you have any questions, you can write in the comment box. I'll try my best to answer your queries. Okay, thank you.